Question number 96. Hybridization of xenon and XiO2F2. I'll just draw the structure first of all. XiO2F2. So this is, here's a lone pair over here. Two fluorine atoms are joined in this way and two oxygen atoms. This is the structure, and in this case we have the hybridization we can calculate with the help of simple formula. That is equal to total number of sigma bonds in the species plus number of lone pairs. So in this case, total number of sigma bond, if you count, these are 4. One lone pair is there, so total is 5. On the basis of this, hybridization would becomes sp3d. 5 orbitals we have already find out with the help of this trick. So sp3d is the hybridization. Where it is given, it's given in option 3. So correct answer is option 3 for this question. Let's take next question. Question number 97 we have. Which of the following is correct statement? We have different statements given here in option 1. O2 and O2 negative. Both are diamagnetic. This is an incorrect statement because if I talk about O2, that's a paramagnetic molecule while O2 negative is diamagnetic. Further, next statement, N2, 2 negative. Both are paramagnetic. This is also an incorrect statement because N2, 2 negative is paramagnetic and N2 is diamagnetic. After that, third statement, C2 molecule contains a double bond. Yes, it contains a double bond, but with 1 sigma and 1 pi bond. This is incorrect. Both the bonds present in C2 molecule are pi bonds, not 1 sigma, 1 pi. This is also incorrect statement. Now last statement, N2 negative and O2 positive. Both have same bond order. Yes, in both of these cases, the bond order is 2.5 that you can obtain with the help of molecular orbital theory. This statement is the correct statement only, and on that basis, the correct answer for this question is option 4. After this, question number 98. Question number 98. For a sparingly soluble salt of type A2B3, Ksp and solubilities are related as. In this case, we have A2B3. This is sparingly soluble salt. So, the ions are formed in this way. This is 3 positive plus 3B2 negative. Let's assume the solubilities for these two cases, 2 is here and 3 is here. So what would be the Ksp value? That is equal to 2s raised to the power 2 and 3s raised to the power 3. So this would becomes 4s square 27s cube. So this would be 108 s raised to the power 5. This would be the Ksp value for this salt. And now this is the relation. Ksp is equals to 108 s5. So answer becomes option 2. Let's take question number 99. For the hydrolysis of HCOOK, this is potassium formate, which is not correct. If I talk about potassium formate, it is a salt of formic acid and KOH. It means weak acid and a strong base. So solution is definitely basic. Fourth option is correct here. If I talk about the pH in the third option, 7 plus half of pK plus half of log C. This is also correct. So I'll just mark a tick here. These two are correct. First one is KH is equals to KW by KA. This relation is also correct. Let's check the last one. Second option, H is equals to root KW by KA. This is an incorrect relation because H is equals to root of KW upon KA into C. So this is the correct relation. So only one option is correct here, that is option 2, that you can choose. After that, question number 100. For the combustion of solid benzoic acid at 27 degrees Celsius, delta H and delta E are related as. Delta H and delta E are in kilocalorie per mole. In this case, first of all, I just want to tell you the relation. between delta H and delta E. That is delta E plus delta Ng RT. This is the relation. Now, if we talk about the process of combustion of benzoic acid, that I'm just going to write in the form of chemical equation, CO2 and H2O is formed. In this case, 7 CO2, I'm just balancing the reaction. This would become 15 by 2. So what would be the value of delta Ng? That is equal to 7, because we have to consider the gaseous modes, benzoic acid in solid state, oxygen in gaseous state, carbon dioxide in gaseous state, and water in the liquid form. So it would become 7 minus 15 by 2, and this would give you minus 1 by 2. This would be the value of delta Ng. So this delta H is equals to delta E plus half into. What's the value of R? R is 2 calorie per mole. If we are taking delta H and delta E in kilocalorie, then definitely R should also be in kilocalorie. That becomes 2 into 10 raised to the power minus 3 into, what's the T value? 27 degrees Celsius. Just at 273, it becomes 300 Kelvin. And now just solve this. Delta H is equal to delta E minus 0.3. This you will obtain. And if you check the given options, this value is given here in option 1. Actually, this can also be written as delta E is equals to delta H plus 0.3. The final relation, on the basis of that, I can choose option 1 as the correct option. After this, next question,